Myself, Sweta Bijali Maiti, Assistant Professor of Haldia Institute of Technology from Applied Electronics and Instrumentation Engineering Department. So, good afternoon, all of you. Today, I am going to discuss a topic on source transformation method. So, before going to the source transformation, you should know what are the energy sources. Energy sources may be independent or dependent. And independent may be voltage or current sources and dependent may be voltage or current sources. First discuss what is ideal voltage source. An ideal voltage source is a two-terminal device whose voltage at any instant of time is constant and is independent of current drawn from it. Such a voltage source is called an ideal voltage source and have zero internal resistance. But practically an ideal voltage source is not possible. Sources having some internal resistances are called practical voltage source. Due to that, the terminal voltage is not constant. Now, symbolic representation of ideal voltage source. This is the symbolic representation of ideal voltage source. This source having no internal resistance. And this is the graph. Then discuss the symbolic representation of practical voltage source. This practical voltage source having internal resistance R, small r. That's why the terminal voltage not constant. This is the graph. Now current source. First discuss ideal current source, after that practical. What is ideal current source? An ideal current source is a two-terminal circuit which supplies the same current to any load resistance connected across its terminal. It has infinite resistance. Practically, an ideal current source is not possible. A current sources having some internal resistances connected in parallel are known as practical current source. Now, the symbolic representation of ideal current source. This is the symbolic representation and graph. Now discuss source conversion or transformation method. A practical current source can be converted into its equivalent practical voltage source and vice versa. We can convert a practical current source to its equivalent practical voltage source. Again, we can convert a practical voltage source into its practical current source. Suppose this is a source and RL is the load resistance. Now, this can be represented as a voltage source and current source. Vs and Rs is the series resistance, RL is the load resistance. This is the voltage source representation, and down one is the current source representation. How we can calculate Is? We know from the Ohm's law, I equals to V, V is equals to IR. So I will be equals to V upon R. And that particular Rs that is connected in series in voltage source, that is connected in parallel in the current source. Now, how we can convert a voltage source to current source? This is the example. Replace a voltage source Vs in series with a resistance R by a current source Is in parallel with the same resistor R. Vs is 100 volt and R that is connected in series 50 ohm resistance. How we can convert? We know from the Ohm's law. Just apply Ohm's law. Is will be equals to Vs upon R. Vs value 100 ohm, 100 volt, and R 50 ohm. So Is will be equals to 2 ampere, and that particular R connected in parallel for the current source. Now, how we can convert a current source to voltage source? Replace a current source Is in parallel with a resistor R by a source voltage source Vs in series with the same resistor R. Is 2 ampere and R that is connected in parallel 50 ohm. Then how we can convert that practical current source to the practical voltage source? By applying Ohm's law, we know Vs will be equals to Is into R. 2 ampere multiplied by 50 ohm, that means Vs will be equals to 100 volt. Then Vs and that particular R connected in series with that Vs. Now this practical current source converted into its equivalent practical voltage source. Now suppose some ideal voltage sources connected in series, then what will be the equivalent voltage? Then the summation of these two voltage sources will be equals to the equivalent voltage V1 plus V2. Suppose two ideal current sources connected in parallel, then what will be the equivalent current? Equivalent current will be equals to the summation of these two current source, I1 plus I2. Suppose two practical current sources connected in series, then how we can convert that two practical current source into one current source? So first convert these two current sources into its equivalent voltage sources. After that, these two voltage sources connected in series, now the summation of these two voltage source will be equals to the equivalent voltage, and as these two resistances connected in series, then the equivalent resistance will be equals to the summation of these two resistances. After that, convert that particular voltage source into its equivalent current source by applying Ohm's law. Then we can convert two current sources that is connected in series converted into a single current source. Suppose two practical voltage sources connected in parallel. How we can convert these two voltage sources into a single voltage source? First, convert these two practical voltage sources into its equivalent current sources. After that, as these two current connected in parallel, so the equivalent current will be equals to the summation of these two currents. And as these two resistances connected in parallel, then the equivalent resistance will be equals to R1 R2 upon R1 plus R2. Again convert this practical current source into a equivalent voltage source by applying Ohm's law. Then we can easily convert, if two current sources connected in parallel, then convert into a single voltage source by using this procedure. Now, if I discuss one example, then it is clear source conversion method. Suppose this is a one example, this is a network, and reduce the network shown in figure to its simplest possible form by using source transformation. This network having four voltage sources. So first convert these four voltage sources into its equivalent current source. So if we convert these four voltage sources into its equivalent current source, then we get this type of network. After that, convert this equivalent, as these two current sources connected in parallel, then the equivalent current will be equals to summation of these two currents, that means 10 ampere. And the next part, Here also two current sources connected in parallel, so the equivalent current. Now these 2 ohm and 1 ohm, these two resistances connected in parallel, and here also 2 ohm and 1 ohm connected in parallel. Now the equivalent resistance will be equals to 2 upon 3 ohm, and here also 2 by 3 ohm. Again convert this 10 ampere and 2 by 3 ohm resistance, this practical current source, into its equivalent voltage source. So equivalent voltage source will be equals to 20 upon 3. And this 2 upon 3, that resistance connected in series with that particular voltage source. And here also 6 ampere and 2 by 3 ohm resistance is converted into its equivalent voltage source. Then we get 4 volt and 2 by 3 ohm, that resistance connected in series. Now this 4 volt and 20 by 3, that voltage source is connected in series. Then what will be the equivalent voltage? Equivalent voltage will be the summation of these two voltage sources. As the direction is different, that means it will be equals to summation of this. If it is V1, it is V2, then V1 plus V2. And as this 2 by 3 and this 2 by 3, that connected in series, then the equivalent resistance will be equal to summation of these two, and that will be equals to 4 by 3 ohm resistance. So now this network converted into a simplest network, where the network having only a one voltage source and a single resistance. So thank you all of you. I think all of you understand this lecture.